So let's go over how to do expected value and the standard deviation for expected value on Excel. So what we're going to do is we're first going to just build a probability model. So let's look at number 3. This will be our example problem here. And our A says create a probability model. Well, the probability model is this entire table that then gives you that expected value answer. All right, so here we go. You draw a card from a deck. If you get a red card, you win nothing. So I always put X as my outcome. It says I win nothing, so that's a 0, and a red card. So a red card is 26 out of 52. All right, then it tells me that if you get a spade, you win $5. So my outcome is 5. The chance of getting a spade, the probability of a spade, is 13 out of 52. Next, it tells you that if you win a club, if you get a club, you win $10. Well, the chance of getting a club is 13 out of 52. But then it tells me something kind of interesting here. It tells me that you win an extra plus an extra 20 for the ace of clubs. Okay, so if I win 10 for a club and then 20 for the ace of clubs, that makes a total of 30 in a very different situation. So I'm going to actually put 30 here, 10 plus 20, for an ace of clubs. Well, how many ace of clubs are there? 1 out of 52. There's only one ace of clubs. But the problem now, I do have a little bit of a problem here. My problem now is that this doesn't equal 1. I've added this up, 26 plus 13 plus 13 plus 1, that's 53. And the reason is that I'm counting for the ace of spades twice. Once for all of clubs and once here. So I'm going to actually, if I'm going to do the ace of clubs right here, for this one, I'm going to actually have to change that number from a 13 to 12. So I kind of always have to be really on my toes. All right, so now I have all of these. I'm just going to do a really quick check. I want to make sure, do they add up to 1? Okay, because we know that they always have to add up to 1. So I'll just highlight those, do sum. It adds up to 1. Okay, I'm all good. All right, now I'm going to multiply across. So we simply do x times p right here. That's 0 that time. I'm going to just autofill that all the way down. And then I sum them all up. So to sum them all up, you simply do sum, double click on sum, and highlight. Okay. So I have $4.13. Now if you got this and it wasn't, say your answer actually looked more like this, sorry about that. That's because I want to make sure that we're talking about money, so I want my answer to be about money. So I'm going to go up here and I'm going to turn it into currency. So that's why that $4.13. How much would I be willing to pay? All right, so I've done B. I found the expected amount. I've got my model here. Now C, how much would I be willing to pay? Well, essentially, theoretically, I'm willing to pay any amount of money if I actually win something. So I actually would be willing to pay $4.12, okay? Or any amount smaller than that, because that guarantees that I win at least a penny. And that's ridiculous to win a penny, but if I played it 1,000,000 times, I'd have $100,000 on average. So there's number 3. Now I want to go to the next level, which is number 11, which is finding the standard deviation for this. So standard deviation, we have that equation right here. Okay, so I got to do this crazy equation. So definitely the thing I got to start with is x. So my x's, well, I have them right over here. So I'm going to do some copy and paste. So if I hit Control C and I click over here and I hit Control V, it glues it all there. So now I have my x's. But I now have to do the first part of this equation, which is x minus expected value, and square that. So that's going to equal, okay, parentheses, exactly, so I'm going to copy exactly what I see here. X, I just always reference it, minus e of x, well, that's right here. Now it's always, no matter which one I'm looking at, it's always going to be this e of x. So I am going to do something you might remember from a while back. I'm going to do something called absolute reference. I'm going to make it so that it always references this exact cell if I autofill. So I click F4, and the F4 puts those $ signs in. Then I'm going to do end my parentheses, and it says I have to square it. So I do Shift 6, I put that caret there, tells it to square it, and now I should have an answer. I can do that again if I need to. Again, I put parentheses, I highlight this, subtract my x, which I know I'm going to keep using it, and I want to autofill eventually, so I'm going to hit F4 here. Parentheses, whoopsies, sorry, Then I do my parentheses, caret, and square. Okay. At this point, I can just autofill because it's the same every time, and since I absolute reference this, I know that will stay the same, but the actual x's will change. So I autofill there. All right. And now I need to take this answer and I have to multiply it by p. So that's going to be equal that times, and my p is right here, 0.5. Enter. Now, since it's going to be the same all the way down, I can just autofill that all the way down. Then I do the summation here. So equals sum. I'll just add that all up. The last step to finding my standard deviation is the square root. So that's going to equal, square root is SQ. You'll start to see it right there, SQRT. Click on your reference cell, hit enter, and there is my answer. So I have a standard deviation of $5.44, which is interesting because that's bigger than what I make, which means I can on average make a ton of money, right? It could go out past, over doubling it to like $9, and what would that be, 66 cents. It also means, though, that oftentimes it can go below and I can come in the negative. So if I am risk averse, this large standard deviation, something bigger than my average, is going to make me really hesitate on playing this game. However, if I'm risky, I might say, look, that large standard deviation means I can win on average way more than I ever thought, so I still might want to play.